to this lesson on triangle classification. There are going to be several slides here at the beginning you're going to take information from, whether you do it from a screenshot or jotting some notes down. Just want you to be prepared on that. I will pause and discuss a few of them, but some of them we'll just move on through, so if you need to, pause the video during those. So beginning with the idea of a triangle, we have the sides AB, BC, and AC as sides of the triangle ABC, and then each of the individual letters represent a vertex. So A, B, and C individually are vertices of the triangle. The triangle sum theorem, real basic, it says that triangles, all the three angles in a triangle, sum to 180 degrees. If you need to pause this to write that down, feel free. Now I'm just going to kind of flow through these slides on the different classifications of triangles. They're pretty self-explanatory. So slide 1, slide 2, slide 3, slide 4, slide 5, slide 6, slide 7. Now an auxiliary line is something that we can actually add. So it's not part of the original picture, but we have put this line in to create a couple more angles, in this case particularly angle 4 and 5. And we would use that by making line L parallel to line AC. So I would make this line parallel to line AC. And what that's going to mean is that angle 1 and angle 4 are alternate interior angles and therefore congruent. And the same thing for angles 3 and 5. They would be alternate interior angles and so also congruent. So what that tells me is that 1 is the same as 4 and 3 is the same as 5, so I could think about replacing these. These are the same. It's not technically correct notation, but just to save a little time. That is an awful looking 3, but it is what it is. So 1 and 3 could replace 4 and 5 here, and you'd have 1 plus 2 plus 3 measuring this straight line, line L here. Well, the measures that sum to a line, to a straight angle, add up to 180 degrees. So if 1, 2, and 3 add up to 180 degrees, then the angles in this triangle, which are 1, 2, and 3, have to add up to 180 degrees. That's a simple proof of the triangle sum theorem. Okay, a couple corollaries here. They're real basic, so I'm not going to spend time talking through them. So you can jot down anything you want off of these. Okay, talking about the interior and the exterior of a triangle. When we talk about the points in the interior, let's make sure we're clear. This is a point in the interior, right here. This is a point in the interior. This is a point in the interior. So anywhere inside the triangle is the interior. This is a point in the exterior. This is a point in the exterior. Any point outside the exterior. Outside of the triangle is the exterior. And then we use that idea to talk about interior angles and exterior angles. So 1, 2, and 3, angles 1, 2, and 3 are interior angles. Angle 4 is an exterior angle. And we're going to use that for a theorem here in just a second. But we need to understand that the exterior angle has to be outside the triangle, the interior angles have to be inside the triangle. So what we're going to talk about here is remote interior. Basically, there's 3 interior angles, 1, 2, and 3. So for this angle 4, right here, the exterior angle, there's 2 angles that are called remote interiors, and that means that they have to be away from angle 4. They can't be connected. Now, angle 3 is connected to angle 4, so it's not a candidate. So the only other 2 interior angles that are not connected to angle 4 are angles 2 and 1. So 2 and 1 are what's considered the remote interior angles as compared to angle 4. Now, I can also extend this side here. Whoops. Back. I can also extend this side here, like so, and create an angle 5 that's an exterior angle. Now from angle 5's perspective, it's connected to angle 2. So angle 2 could not be considered a remote interior angle for angle 5, but angle 1 and angle 3 are two interior angles not connected to angle 5, so 1 and 3 would be remote interior angles. And real quickly, I could do this for, I could do this way as well and create an angle 6, and these would be the remote interiors, 2 and 3. Okay. All right. So here's the exterior angle theorem, which what it says, if I take the exterior angle here and its remote interior angles, the two remote interior angles have to sum to equal the exterior angle. This should make sense because the exterior angle and the adjacent interior angle are supplementary. They'd have to add up to 180. Well, this angle 3 here has to add with angles 1 and 2 to equal 180. So obviously these two angles have to add up to whatever 4 is. The third angles theorem, this is a real basic theorem. Basically, if I've got two angles in one triangle that are congruent to two angles in another triangle, because the two triangles have to have the same sum, namely 180 degrees, if the two angles in one triangle sum to 100 degrees, and the two angles in the other triangle also sum to 100 degrees, then there's only one angle left for each of them. It's got to be 80 degrees. So the third angles, if two angles are congruent in one and the same two angles are congruent in another one, the third angles are going to have to be congruent by default. There's no other choice but for them to be congruent. Okay, so now let's use this idea. We're supposed to find the value of x. So I see the markings. I see that I have two sides that are congruent. So I want to find the side lengths. This is based on an isosceles triangle. I'll set those two sides, 4x minus 10.7, which is side JK, and the length 2x plus 6.3, representing side KL. I'll set those equal to each other because those segments are congruent. So a quick little bit of algebra, I'll subtract 2x from 4x, and I'll add 10.7 to 6.3, leaving me 2x equals 17. You should be able to handle that. That's just Algebra 1 review. Then divide by 2, and we have an 8.5 for x. So I'm supposed to find the side length, so now what I'm going to do is take that 8.5 and plug it back in. So plugging it in for JK, 4 times 8.5 minus 10.7, giving us 23.3. And then you can see how we plug in for the other two sides. Fairly straightforward. So we see that JK and KL have the same length, which they should have, since they were congruent. And then JL, the base side for that isosceles triangle, has a different length. Okay, we have an equilateral triangle. Here we have a little bit of freedom, because if it's an equilateral triangle, all three sides are congruent. So let's make sure we understand what we're looking at here. This side, and this side are all congruent. If they're all congruent, I can pick any two of them that I want and set them equal to each other. So the slide, I'll have two particular ones, but you could do it in several different ways. You could pick any two sides and set them equal and solve for y. You'll get the same answer no matter what you do. So what I've got here is side FG and side GH. I've set those two equal, but I could have picked FH and GH and set those equal, or I could have picked FH and GF and set those equal. It would have given me the same answer either way. So real quickly here, I'm going to subtract 2y, and I'm going to add 4. So I'm going to get y is 7. Now I know what y is. If I wanted to, I can plug back in and find the lengths of each side. So that's what we'll do here. Plugging in 7 for each of these. Again, fairly routine procedure. You should be able to handle that. You see that all three sides were 17, which goes along with the fact that this was an equilateral triangle. All three sides should be the same. Okay, so if one of the acute angles in a right triangle measures 2x, what is the measure of the other acute angle? Okay, common mistake here. Right triangles, you know one of the angles is a right angle, so you have two angles left. A lot of people will look at this problem and say, well, if one angle is 2x, the other angle is 2x. And the reason they'll say that is you get locked into this idea if you have a right triangle, then the other two angles must be 45 and 45, meaning that they're always equal. But remember, a right triangle, I could have 30 degrees, 60 degrees, and 90 to make 180 degrees. I could have 10 degrees, 70 degrees, and 90 to make, 10 degrees, 80 degrees, and 90 to make 180 degrees. I could have a lot of different measures for those other two angles. The key is, if one of the angles is already 90 degrees, there's only 90 degrees left in the triangle. So whatever one measure is, I would subtract it from 90 degrees. So if I tell you that one of the angles in a right triangle, one of the acute angles, is, say, 20 degrees, then the other angle has to be 70 degrees, because I would take 90 minus 20. But what I'm telling you here is that one of the angles is 2x. So the other angle has to be, excuse me, having a little bit of keyboard issues tonight. Sorry about that. The other angle has to be 90 minus 2x. So let's make sure we see that. If I draw this picture, I already know this right angle. So let's just say that, like I said before, this is 20 degrees. Okay, so I want to know what this angle is. Well, 90, 20, and some other number equals 180. Well, since this is 90, I already know all three have to add up to 180. These two have to add up to 90. This is 20. That makes this 70. The way I can do that is to say 90 minus 20 is 70. Well, this time I was told that this angle, instead of being 20, it's 2x. So if it's 2x, then this other angle is going to be 90 minus 2x. I'm just going to take 2x away from the 90 degrees that has to make up those two angles. So be very careful that you don't assume that these angles have to be 45 and 45 every time. That is a common mistake we see consistently in geometry classes. Students see a right triangle and they go, oh, 45 and 45. It's not true. There's a bunch of different options for what these two angles can be. They just have to sum to 90 degrees. Okay, so the measure of one of the acute angles in a right triangle is 63.7 degrees. What's the measure of the other acute angle? So you know you have a right angle and you have 63.7. So the 63.7 and the other acute angle have to measure to 90, because those two angles plus the right angle would make 180 degrees in your triangle. So you're just going to subtract 63.7 from 90. Straightforward. You get 26.3 degrees. Okay, here I want to find the measure of angle B. This is using the exterior angles theorem. So what I have is my exterior angle is right here, and it's going to equal the sum of my remote interior angles. So I've got to add these two together and set them equal to my exterior angle. So my remote interiors add to equal my exterior. That's the equation I'm going to set up. Measure of angle A plus measure of angle B equals the measure of angle BCD, which is this angle right here. Plugging those pieces in, you see what I get. A little simplification. I have 2x plus 18 equals 5x minus 60. I'll take the smaller x over by subtracting 2x from both sides. which means I'll then have to add 60 to the 18. So I've got 3x equals 78. Dividing by 3, x is 26. Now I was asked to find the measure of angle B, so I'm going to have to plug back in to 2x plus 3 with 26 degrees for x. So I end up with 55 degrees for the measure of angle B. You can pause the video if you need to. Here I want to find the measure of angle ACD. We're talking about this angle right here. What I know is that's an exterior angle, and the remote interiors are this one and this one. So one of them is a 90-degree angle. So the 90 plus the 2z plus 1 is going to equal the exterior angle 6z minus 9. In terms of the actual angles, angle ACD, the exterior angle, is going to equal the measure of angle A plus the measure of angle B, the two remote interiors. Plugging those values in, a little simplification, and I'll now subtract 2z from 6z and add 9 to 91, leaving me 4z equals 100, so z's got to be 25. Now if I'm trying to find the measure of angle ACD, then I need to plug back in to 6z minus 9 with 25. So I'm going to get 141 degrees for that angle. Once again, pause if you need to. Here I want to find the measure of angle P and the measure of angle T. This is using the third angles theorem. As you see, I have 2 tick marks for angle N, 2 arc marks. I also have 2 arc marks for angle S, so those 2 angles are congruent, N and S. I have a single arc mark for angle M and a single arc mark for angle R, so M and R are congruent. So I have 2 angles in the first triangle congruent to 2 angles in the second triangle. That means that the third angles, which in this case are represented by angles P and angle T, have to be congruent. So I'm going to give those 3 arc marks. But those are the ones represented by the variable expressions, 2x squared and 4x squared minus 32. So I can actually set those two equal to each other, because angle P is congruent to angle T. Now I'm going to set them equal. And at first you're thinking, wow, I've got to deal with this square. It's not as bad as you think. If I go through and simplify this by subtracting either the 4x squared over and then dividing by -2, or subtracting 2x squared on this side and adding 32 to the other side, whichever method you prefer, I'm going to end up with x squared equals 16. Okay? Now it asks me to find the measure of angle P and the measure of angle T. So first you think, well, I've got to now take the square root. But if you look back at the measure of angle P, the measure of angle P is 2 times x squared. Not 2 times x, 2 times x squared. I know what x squared is. It's 16. So 2 times 16 is 32. So the measure of angle P is 32, which means the measure of angle T is 32, since they're congruent. You can pause if you need to. Okay, now this picture looks a little daunting at first, but basically what's happening is you have 2 triangles that are overlapping. So what I'm going to do is I'm going to color the triangles a little bit here so you can distinguish what we're looking for. So the first triangle I'm looking at, right here, I'm just going to outline it so you can see what I'm talking about. So I've got that triangle. Now I'm going to look at the other triangle, and it's going to look like this. Okay, so we have these 2 triangles. Well, here's what I should notice. Angle F in the purple triangle is congruent to angle I in the green triangle. And angle G in the green triangle is congruent to angle H in the purple triangle. So I have 2 angles in both triangles that are congruent to each other. What's that mean for us? It means by the third angles theorem that our third angles K and J have to be congruent. which again leaves me these expressions that I can set equal to each other because those angles were congruent. So I'll subtract the 6y squared over, divide by -2, and get that y squared is 20. And once again, I'm trying to find the measure of angle K and the measure of angle J, which are in terms of y squared, so I don't need to take the square root of this. Measure of angle K is 4 times y squared, so since y squared is 20, I'm going to do 4 times 20 and get 80. Since J is the same thing, I'll also get 80 there, and you can check it. You could plug in and do 6 times 20, 120 minus 40, and again, you'll get 80 degrees. So pause if you need to. Now, for class, I want you to bring in this lesson quiz. So you're going to answer these questions on this slide right here. This slide as well. And there is one more slide, so you'll need to pause. And this is the last slide. So answer those 8 questions, bring them to class. We'll talk through them, give you some formative assessments, and let you get to work. Thanks for listening and watching. Have a great day.